Hello, today I will discuss with you a very common but confusing topic in industrial manufacturing: sandblasting, shot blasting, and shot blasting. These three processes seem to punch the surface, but their purpose and effect are quite different. Today, we will start with an interesting analogy to learn more about the powers of the three brothers and learn how to correctly select models in practical applications to avoid common pitfalls. First of all, we will focus on one core point, distinguishing between sandblasting, shot blasting, and shot blasting. The key is not what equipment is used, but what you want to achieve. For the convenience of everyone's memory, I use three simple tropes to summarize their core functions. Sandblasting is like using a small knife to cut. Shot blasting, like using countless small hammers to hammer, while shot blasting is like using a big hammer to smash. These three actions vividly reveal their respective working principles and focus. Let's take a look at both. Sandblasting. Its core action is chipping, like rubbing workpiece surface with countless small blades. It uses abrasive with sharp edges and corners, such as brown corundum, silicon carbide, etc. There are two main purposes of sandblasting. One is cleaning, efficient removal of rust, scale, and old paint on the surface. The second is to manufacture roughness, to provide good adhesion for subsequent paint spraying and other coatings, or directly produce matte surface effect. There are two important refuge points. First, try not to use coarse sand as it will produce harmful dust. Second, for the surface or threaded hole with precision matching requirements, it must be sheltered in advance, or the accuracy will be affected by chipping. Next is the ode to shot pinning. Its core action is hammer with countless high-speed small particles of abrasive, like a small hammer repeatedly hit the workpiece surface. The purpose of this process is not to remove material, but to strengthen the surface of the workpiece produced by such a strike, a residual compressive stress, which can effectively resist the generation and propagation of fatigue cracks, thereby greatly improving the fatigue resistance life of the part. Therefore, shot pinning is widely used in key parts such as gears, crankshafts, springs, and turbine blades that need to withstand repeated loads. The avoidance point here is: the first, shot blasting used for strengthening must use spherical or near spherical abrasive. Second, pinning of thin or elongated parts may result in deformation, which shall be considered in the design, and deformation allowance shall be reserved if necessary. Finally, the old three, shot blasting. Its core action is smashing the abrasive with a high-speed rotating impeller to the workpiece with huge kinetic energy. The most important feature of shot blasting is its high efficiency, suitable for handling large areas or large batches of workpieces. Its primary purpose is efficient cleaning, such as rapid removal of scale and rust from casting or steel structure surfaces. The avoidance point here is very clear. Do not use shot blasting to treat the finished surface, because the shot blasting will form pits on the surface and damage the original precision roughness, so the parts can be directly scrapped. In order to make you more intuitively understand the differences between the three, we look at this comparison table. From the power source, sandblasting and shot blasting mainly rely on compressed air, while shot blasting is driven by mechanical impeller. Angular materials for sandblasting and spherical or short, cylindrical materials for shot blasting. and shot blasting according to the shape of medium. Critical control points are also different. Sand blasting focuses on cleanliness and roughness. Shot blasting focuses on reinforcement and coverage, and shot blasting focuses more on efficiency. Surface influence. Sand blasting is cutting. Shot blasting is plastic deformation, and shot blasting is impact to form pit. Finally, their typical applications are also focused, and this table can help us make a quick judgment. Knowing the differences, we have to choose. First, look at sand blasting. When your goal is to provide high adhesion to subsequent coatings, or when you need a uniform matte surface, sand blasting is the best choice. Be sure to remember that precise parts must be well protected. Then shot pinning. When you need to improve the fatigue resistance of a part and make it more durable, you should choose shot pinning for reinforcement. But for thin or thin parts, special attention should be paid to deformation risks, and process parameters should be evaluated in advance and strictly controlled. Next, look at shot pinning. When you need to process large quantities of castings and forgings for greater cleaning efficiency and minimum cost, shot pinning is optional but never used on finished surfaces. At last, there are two general avoidance pits. First, avoid using iron abrasive when processing aluminum, stainless steel, and other materials. Otherwise, iron pollution will be caused and unsightly rust will be formed. Second, all processed workpieces shall be put into the next process as soon as possible to prevent flash rust in the air from being completely destroyed. Finally, it is also the most critical point. It is far from enough to only write sand blasting or shot blasting in the technical requirements. The acceptance criteria must be specified. For the cleaning type of sand blasting or shot blasting, the cleanliness level shall be specified, such as Ra 3.2 to 6.3 microns. Meanwhile, it shall be clearly pointed out which areas do not need to be treated, such as ISO 85011, SA 2.5 and roughness range. For reinforced shot pinning, the arc height, coverage, and specific abrasive type must be specified, such as S110 steel shot rather than steel shot in general. Finally, we summarize the core content with a sentence. Sand blasting edges and corners, abrasive cutting, surface cleaning and roughening, shot blasting spherical texture hammer, surface strengthening and anti-fatigue, shot blasting centrifugal impeller heating, effective surface peeling. We hope that you remember this recipe and select the right process to achieve twice the result with half the effort. Thank you.